In this one, we'll be drawing the graph of a following linear function for a domain -5, which is less than or equal to x, which is less than or equal to 5 on the graph paper for these two functions here. So we're going to be doing it various methods, but first let's start by constructing the table of values. All right, what is the table of values? The table of values is where you will put in the domain, you can put in the equation in there likewise, and using the table of values afterwards, the graph of the linear function given the domain will then be drawn on the graph paper. So let's start by drawing the table of values. So we know that definitely we need an x. So I'm going to start for this one here, x, and the first value is going to be -5, -4, -3, -2, -1. We have 0, 1, 2, 3, 4, 5. Sometimes you may not be given so many values for you to do, but for this one here I decided to do search so that you can see that you can actually get all the values. We know that we will be multiplying, we'll be adding as well, and we will be working with other parts of that same table, and we may use all of the points, but not necessarily we need to use them because it's a straight line, or it should be a straight line since we are talking of linear functions in this topic. So I'm going to draw a next line here, and the reason why I'm going to draw a next line here is because we know that the equation states 4x, which means multiply the x and then you are going to add a 1, so you add a 1. So everything will be added 1 because it says to add 1, 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 add 1. Okay, now here at the bottom is where we will have the function fx maps to 4x plus 1. Okay, so we're going to start working with the -5 and the 4 because this tells you 4 times x, and what's the value of m of x? -5. 4 times -5, that gives us -20. 4 times -4, that gives us -16. 4 times -3, that gives us -12. 4 times -2, -8. 4 times -1, -4. 4 times 0, 0. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. Okay, now as it states here, -20 plus 1, so we need to recall the laws of adding integers. So this gives us now -19, -15, -11, -7, -3, 1, 5, 9, 13, 17, 21. If you were expecting to see that they would be almost the same values or the same values, no. Remember here we are having negative and we're adding a positive value. Here we're having a positive and we're adding a positive value. So now we have our values, our table of values. Okay, so this is what is known as a table of values. So once you're given a function and you have the range here, the domain here, then you are to use that for your x values here. And then notice the 4x, I put 4x here. The second operation, I put it here. And then the last piece is where you will get the total for each one of them. So now I'm going to bring my my graph paper. A key point here for us to note is that let's see what will be our extreme left hand side and extreme right hand side for our x, as well as for our right, as well as for our vertical values, which will be for the y. For the y we will need -19 and 21, so -19 to the bottom and 21 to the top. So we get our graph paper, which is here. So I'm going to put my table here to the side so I could then do our graph paper. You may decide to take 1 centimeter from here to here is 1 centimeter, and in between zoom in, there are 10 little lines which are millimeter. So we could get 1 centimeter to here, 2. So this would be 1.1, 1.2, 1.3, 1.4, and so forth. But we're not going to go to such an extreme. Okay. So for this sake, for this purpose here, I know that my graph paper should go to the top 21, to the bottom 19. So that's going to give a 40 total. It won't fit here on this graph paper. So I'm going to take that from here to here is 1, 2, 3, 4, 5, 6. That's what I can do. Or I could take even furthermore and use values as to say from here to here as 1, 2, or 2, 4, 6, 8, 10. So every half of centimeter is actually 2. Okay, so we can do that. So let's do that for, because the graph will be big, and if you notice, this is just to graph this graph paper. So we can use that method, or we can reduce the amount of values that we want. We can, let's say for our purpose, for it to fit perfect, we can use this set. Notice it won't be much. Okay, so we can use that also. So for this purpose, let's reduce it to this amount and see where that takes us. -3 to +3, that will be our table, so that it can fit perfectly on our graph paper and we won't need to be going in between the centimeters. Okay, so that's 24 on the vertical axis. Let me see, 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Excellent. So we're going to be taking and plotting only this graph here from -3 to +3 for the purpose of our demonstration. Okay, and then we're going to be dealing with graphs afterwards that expand more than what can fit in the graph paper. So for the x is going to be from -3 to +3. So I can choose that, and then I will need from the vertical axis from 13 to 11, that's 24. So let's start by doing that. I'm going to go on the extreme end at the top here, and I'm going to put here 13. Draw the line instead so we can fit that perfect. That's going to be our vertical axis. Remember, usually we don't have graph such big, but for this purpose we got this. So here we have 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 at the center. So I'm going to draw my horizontal axis, which is the x-axis. There you have -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11. So for the purpose of this video, we are only choosing the values from -3 to +3 for the x. So we have here 1, 2, 3. We have here -1, -2, -3. Look how squeezed up this graph will look. So we're going to start plotting our points now. Our first point to plot will be -3 and 11. So when x is equals to -3, as it says here, x is equals to -3, y will be -11. So I come here now and I put, so find -3, and I go to -11, which is way down here. Okay, so you're going to put a dot and do a circle, and then you're going to go for the second point, which is -2 and -7. So -2 and -7 right there. Then we're going to go to -1 and -3, -1 and -3 right there, and then we're going to go to 0 and 1, 0 and 1 right here, and then we're going to go to 1 and 5. So we go here 1, and we go up 5, and then we're going to go 2 and 9. So 2 and 9, and then we're going to go to 3 and 13. So 3 and 13. Usually we would pass one value extra, but for this purpose we're not. Okay, so looking at the points now, I should be able to take my ruler and draw a straight line that passes through all of the points, because we are talking of linear functions and everything that we are working with should be straight line for this purpose. Okay, so I take my point there and I draw my line to the top, and so we have all our points right there on the line. So what we have done, we have drawn our linear equation, and so we have our function. So at this point I want you then that you are to write the function fx equals 4x plus 1. Tell me that that's the equation. And at the same time, looking from this graph, you could see that 4 is the gradient. So you are going to put here now that for this graph we have m is 4, and if you notice, the y-intercept here is positive 1, which is here. So you're going to put here now that c is equals to 1 right there. So you have drawn a table, plotted all of the points for the function, you have identified the gradient, you have identified the intercept, and notice that's the function of it. So that's using the table for such graph.